Why are SCADA alarm management systems ineffective? Have you ever wondered why some alarm systems in industrial settings seem to fail when we need them most? Today, we will look into the reasons behind the ineffectiveness of supervisory control and data acquisition alarm management systems. These systems are essential for monitoring and controlling processes, but issues can arise that hinder their performance. One major problem is alarm overload. When too many alarms are generated, operators can become overwhelmed. This can lead to alarm fatigue, where important alerts are missed or ignored. The technology itself is not the issue. Instead, it is how alarms are configured and managed. Modern supervisory control and data acquisition systems, which work with programmable logic controllers and distributed control systems, can easily generate alarms. This ease of setup often results in too many alarms being enabled without proper justification. When every alert is flagged as important, operators struggle to identify which alarms requiring immediate attention. Another factor is the lack of contextual or state-based alarming. Most alarms are set for a single process condition, typically during steady-state operation. However, processes often go through various states, such as start-up or shutdown. Without state-based alarming, operators receive nuisance alarms during these transitions, which can distract them from real issues. Additionally, poor prioritization can lead to alarm flooding. When alarms are not properly prioritized, critical alerts can get lost among lower priority notifications. This makes it challenging for operators to pinpoint the root cause of a problem. Capturing the first alarm in a sequence is vital for effective troubleshooting. Inadequate system design and planning also play a role. Effective alarm management requires a well-thought-out design plan that involves both operators and engineers. If alarm criteria are set arbitrarily, it can lead to inappropriate thresholds and unnecessary alerts. Balancing sensitivity with selectivity is essential to avoid false positives. Human factors cannot be overlooked either. When operators face frequent alarms, they may start resetting them without proper investigation. This behavior reduces the overall effectiveness of the system and can lead to safety risks. Many supervisory control and data acquisition systems also lack advanced alarm management techniques. Features like alarm shelving, which temporarily suppresses alarms, or dynamic alarm suppression based on process conditions, can help reduce nuisance alarms. Unfortunately, these features are not always available. Cost and system constraints can further limit the effectiveness of alarm management. Some supervisory control and data acquisition systems, especially those based on programmable logic controllers, may have limitations in handling complex logic or alarms compared to distributed control systems. This can restrict the implementation of advanced alarm management strategies. To improve alarm management, electrical engineers can implement alarm rationalization. This involves reviewing each alarm for necessity, priority, and correct setpoints. State-based alarming can also be utilized to adjust alarm conditions based on operational modes. Designing systems that highlight the first fault in a sequence aids in root cause analysis. Training operators to interpret alarms correctly is vital. Regular maintenance and updates to alarm configurations can ensure they reflected current plant conditions. Employing advanced features like predictive analytics can help anticipate faults before alarms trigger. In summary, the ineffectiveness of supervisory control and data acquisition alarm management systems stems from poor configuration, lack of process context, and human factors that lead to alarm overload and fatigue. By focusing on system design, prioritization, and operator interaction, we can enhance alarm effectiveness and ensure safer, more reliable plant operations.